All right, now I'm going to finish up the section 5.8, applications of trigonometric functions. And 5.8 deals with applications that are involving just right triangles. All right, and there's several applications I could have done, but I chose to look at bearing problems with you. Okay, so this is a means of describing the relative location of a point, the location of a point relative to another one. So for instance, let's say I have a point A here and have a point B over here. All right, they might want to know what is the bearing. So if they wanted to know what is the bearing, okay, and they might say from A to B, or they might word it and say, what is the bearing of B from A? And it would mean the same thing, okay? And when we're talking about these bearing problems, they have a similar form. They're going to look like this. You're going to have something you put right here, and you'll put either north or south. So you'll tell somebody whether they have to go north or south. Then right here, you'll put the degrees. This will be the degrees from the north-south line. Okay, so degrees from vertical, which is different than you're used to. It's not the degrees from the x-axis anymore. It's the degrees from the vertical, okay, from the north-south line. And then you'll tell somebody whether they need to veer east or west. Okay, so you kind of need to know this, that if that's due north, this is south, east would be to the right, west would be to the left. Okay, so you need to know that. You need to understand the basics of what you're expected to do. And then you need to be aware when you're reading the language, the from, the point that you're doing it from, that's when you need to think about the axis. So let me change the color now to blue. So I need to think about that being my starting point. So I'm going to draw my axis there, and I'm going to describe to somebody what they would need to do, what direction, how they would need to go to get to B from A, to do that, okay? And so when I try to report that, I have to first tell them whether they should go north or south to start with. So it's definitely going to be north. Do you see that? Okay, so if this is the starting point, then you'd have to go north, and then you'd have to veer this far. So you need to give whatever that angle is. Okay, so whatever degrees that is. So let me just put one in there. Let's say that's 30 degrees. Then you'd put in the 30 degrees. And then see how we had to go to the right towards east. Okay. Then this would need to be east. So the bearing from A to B would be north 30 degrees east. The bearing of B from A would be north 30 degrees east. Okay. So that's the basics of it. So let's go ahead and do a few of these. All right, let's look at 13 through 16. All right. I'm just looking at them to see which ones I want to do and which ones I want you to try before we do it together. Okay. All right, well, why don't I just do, I'll do 13 and 15. I'll do them all, but I'll do 13 and 15, and then I want you to pause the video and do 14 and 16, and then play it and see if you were correct. Okay, so the bearing from O to A. So see how the coordinate axis is there at the O spot. Okay, so that's good. And then we're trying to go to A this time. And so I see this 75 degrees, but that might mislead me and make me use that, and I don't want to use that. So remember how what you do is you tell somebody to go from O to A, whether they need to go north or south. So I can see they would have to go north. Then what I need is that I need the angle from the vertical, but what they gave me was the 75. Do you see how this right here would have to be 90 minus 75 or 15 degrees? So I would go north, then I would veer 15 degrees east. So north, 15 degrees east would be that one. All right, now let me try. I'm going to do 13 and 15 first. Then I want you to pause the video and you go do 14 and 16, and then we'll compare answers. All right, so on 15, I wanted the bearing from O to C. O to C. So here's O. I want to go to C. Okay. So to go from O to C, I would have to go south. All right. And then you want the angle between the vertical and that terminal side. So that would be the 80. I don't have to do any kind of subtraction. I do want to use the 80. And do you see how I went towards the west? So that would be south, 80 degrees west. All right, now pause the video, do 14 and 16, and then start it again and see if you're right. Okay, so now 14 is from O to B. Okay, so when I look at that one, I do need to know this angle from the vertical. So that would be 30 degrees. Since this was 60, that would be 30. So that one should be north, but it should be 30 degrees, and then you're veering to the west. So number 14 should be north, 30 degrees west. And then from O to D, I'm going to need this angle. So that's going to be 55 degrees. 90 minus 35 is 55. And to go from O to D, I have to go south, and then I veer 55 degrees to the east. Okay. All right. So hopefully you had those ideas okay. All right, so let me go ahead and work through some of the problems from 51 to 58. I'll just go ahead and do the odd ones, and then I'll write down the answers to the even ones. If you want to try those and check and see if you got the same answer, you can. I won't work them all out, the even ones, but I'll put the answers, and then if you had trouble with any of them, you can join me in a virtual office hour and we can talk about it. All right, so let's go ahead and work through the odd problems together. So let's look at 51. So this is 51. A boat leaves the entrance to a harbor and travels 150 miles on a bearing of north 53 degrees east. Ultimately, we want to know how many miles north they went and how many miles east they went from the harbor. Okay, so I just kind of think about it. So if this is the harbor, all right, that's where I want to think about. See if I draw that without wiggling. Okay, so that's where I want to think about this. My elbow's off the edge of the table is the problem. Let's try that again. And then, there we go. So I'm going to let that be the harbor. And then the boat is going north 53 degrees east. So we're going to go up 53 degrees, veering 53 degrees to the east. So remember, east is to the right there. So that's the boat. That's the direction the boat is going, right? And then it says the boat travels 150 miles. So this path actually turns out to be 150 miles. And let's say that's where they got to. And it says how many miles north and how many miles east from the harbor has the boat traveled. So they want to know, what is this and what is that? Okay, how far north, how far east from the harbor did the boat travel? Okay, and you know that length right there would be the same as this length right here. Okay, so it doesn't matter whether you draw it up here or down here. All right, but I'm trying to get it inside that triangle is why I use that top one. All right, so I'm looking at that right triangle, and let me clean that up a little bit, just kind of get that 150 out to the outside over here. Okay, that's 150 miles. And I want to know the X and the Y. Let me get rid of those marks right there. Okay, there, that looks good. All right, so let's think about this then. If I wanted to find x and I'm looking at 53 degrees, x is adjacent. The 150 is the hypotenuse and the y is the opposite. So to find the x, I would just do adjacent and hypotenuse. I would do cosine of 53 would equal x over 150. And then to do the other one, the y, I would just use sine. Okay. And so then you would just, for x, you would just do 150 cosine 53. And for y, you would do 150 sine 53. All right, so let's do each of those real quick. Cosine 53. And it says, how many miles north? They didn't say how to round on that. Okay, so why don't we just round to the nearest whole? So this would be about 90 if I rounded to the nearest whole number. And this right here, I'm going to go back up and just change it from cosine. I'm going to hit the sine button, but keep 53 in there. And I get that one to be about 120 when I round. Okay, and the x was north. So you would say for 50, it would be 90 miles north, and it would be 120 miles east. Okay. All right. Okay, let's try 53. All right, 53. Let me see if I can get another page so I can raise this up a little bit. There we go. All right, so let's look at 53. A forest ranger sights a fire directly to the south. A second ranger, who's 7 miles east of the first one, also sights the fire. Okay. All right, so here's Forest Ranger A right here. This is 53. I got another Forest Ranger over here. This is, let me make sure I did that one right. The second ranger was 7 miles east. So I'm going to put him over here. Okay. The first guy sights a fire directly to the south of where he is. So here's a fire that's directly to the south. Okay. And he sees that one. And then we got this guy over here, Forest Ranger B, who also sights the fire. So he also sees it. Okay. And we know the distance between them is 7 miles. Okay. And that tells us the bearings, the bearing of the second ranger to the fire. And then it says how far to the nearest 1/10 of a mile is the first ranger from the fire. So this is the first one. This is the second. We know they're 7 miles apart. What we want to find is this right here. And then we have information about the bearing from the second ranger to the fire. So see how it said from the second ranger? So that's where you need to draw your axes. Let me do it in blue. So this is my north, south, east, west here. And then from the second ranger to the fire, we go south, and then we veer 28 degrees to the west to get there. Okay. So what I really want is to have this right triangle right here. Okay. So I really want that angle, but I can find that because I know it's 90 minus the 28. So that's going to be 62 right there. And then I have a right triangle and I'm looking for x. X is opposite, 7 is adjacent. So I'm going to use tangent of 62 equals x over 7. And so x would be 7 times the tangent of 62 degrees. All right. So 7 tangent 62. And that would be about, and if we just round, let's see, did they say How far to the nearest tenth? That one did say how far to the nearest tenth. So that would be 13.2. About 13.2 miles. Okay, so that would be 13.2 miles right there. And that is how far the first ranger was from the fire. It's 13.2 miles. Okay, so that was 53. Okay. All right, let's try 55. Let's look at 55 together. Okay, so with 55, you leave your house. So let's say that's our house. And you run 2 miles due west. Let me move it over a little bit since I have to go west. Let me put it over here a little further. Okay, so I'm leaving my house. This is my house right here. I'm going to run 2 miles due west. West is to the left, right? I'll go 2 miles. Followed by 1.5 miles due north. And I'm going to go north, 1.5 miles. What is your bearing from your house? Okay. All right, so I'm going to move that down a little bit. I should have read the problem before I drew it, since I have to go north. So I'm going to go this way 2 miles and this way 1.5 miles. Okay. And then it is at that time, what is your bearing from your house? So this is your house right here. So that's where you would want to think about reporting the bearing. So from your house, so you draw your axes are there. Okay. And you need to give your bearings from your house. So you're going to need this angle right here. And you know it's going to be north. So from your house, it would be north, some number of degrees, and then veering to the west. Okay. North, some number of degrees to the west. And you just need to find the number of degrees. All right. So let's put the information we knew. We knew this was 2. We knew this was 1.5. And even though that's the angle I want, okay, it's not real obvious to you unless you've recently taken geometry that that would be this angle up here. This angle would be the same as the one up here. What's more natural is for you to be thinking about, get rid of that letter in there, okay, would be for you to think about that angle. Okay, so that's what we'll do. And so we're going to set up a ratio involving that angle. So that would be tangent. So we know the tangent of this angle right here, just call it theta, has to equal 1.5 over 2. So theta is going to be the tan inverse of that. Okay. All right, so I'm going to do that. Tan inverse. I'm going to go ahead and type in 1.5 divided by 2 and hit the button. And I get the angle to be about 36.869. So I'll say 36.9 degrees. Okay. And let's see, does it say anything about what to round everything to? Let's go ahead and just round that to the nearest whole angle. So that'd be 37 degrees. So this is 37 degrees in here, right? So then I just need to do 90 minus the 37. That gives me 53 degrees. And that would be the angle I really need is this one, because I need the angle from the vertical. So that would be your bearing from your house, north 53 degrees west. All right, so that's number 55. All right, let's see what 57 has to say. All right, 57. A jet is leaving the runway. The bearing is north 35 degrees east from the control tower, whose bearing is north 35 degrees east from the control tower. After flying 5 miles, the jet turns 90 and flies on a bearing of south 55 degrees east for 7 miles. At that time, what is the bearing of the jet from the control tower? All right, let's see if we can draw this. Okay, so this is 57. So here we have a jet leaving a runway. Okay, so let's say here's the control tower. Okay, the runway's bearing is north 35 degrees east. So that would be north, veer 35 degrees towards the east. Okay, so that would be the runway's direction. Okay, after flying 5 miles, so the thing goes 5 miles, and then he travels on a bearing of on a bearing of south 55 degrees. After flying 5 miles, goes south 55 degrees. So I guess they mean from there. Okay, going south 55 degrees, turns 90 degrees, and goes and flies on a bearing of south 55 degrees east for 7 miles. So I'm wondering if that's, yeah, that can't be from the control tower. So it's really weird. So north 35 degrees east is the direction of the runway. He goes 5 miles. And then after flying 5 minutes, he turns 90 degrees, okay, and flies on a bearing of south 55 degrees east for 7 miles. All right, so I'm wondering if they're talking about this 90 degrees. That would be 90. Okay, and so from there, that would be south 55 degrees right here towards the east. The picture's bothering me on this one. Because the north 35 degrees east, that was 35. And if that's 35, then this is 55. Oh yeah, okay, we're okay. All right, I didn't think it matched up with the other problem, but it does. Okay, if this is 35, then this angle up here would have to be 55. So if that angle up there is 55, then this one has to be 35. And so then that would have been 90 degrees. What was bothering me is I didn't think it was going to be 90 degrees, but it does. Okay, so let me go back and make sure I didn't confuse you. So here's the control tower. The plane goes north 35 degrees east and is flying for 5 miles. Then at the end of that, he turns 90 degrees and flies on a bearing that would be south 55 degrees to the east. So that would be this line right here for 7 miles. And then our job is to give the bearing of the jet from the control tower. Okay, so now that we've done it, I can clean it up a little bit and we'll finish it on up. Okay, so let me first off draw in the missing side of the triangle, be right here. Okay, so here's my triangle. The only reason this works is because they contrived it to be 90 degrees right here. There's your 90-degree angle. And then we know the length of this first piece was 5, and the length of this part right here was 7. And we want to know what the bearing of the jet from the control tower would be. Okay, so we really don't need the length of the third side. What we need is what this turned out to be, this angle right here. So that we can figure out from here what they were doing. Okay, so this is harder than it looks. All right, so let me clean up my picture. What I don't know is whether that really, in effect, can't tell yet, whether that's going to go past this line right here or whether it's gonna stop short of it. So I don't know how to actually draw this so it matches what it's gonna turn out to be. So I may not have to adjust it later, okay? So let's suppose it's something like that, okay? And so, let me get this angle right here. So that would be tangent of theta being 7/5. So theta would be the tan inverse of that. Okay. And so when I do inverse tangent 7/5, I get my theta, and that turns out to be, I need more room. So that turns out to be about 54.5 degrees. All right, so I got to kind of think through this a little bit. Okay, so I know this is 35 right here. So I know this little piece right here was just 55 degrees. And so the 54.5 that I got tells me, so this piece, just this piece from here to here was 55. So really the angle, when I drew my picture, that should have been up a little bit. If that's whole angle right there is 54.5, then this should have been drawn differently. So it should have been drawn up a little bit because it's a little shorter than the 55. So it should have been just barely up from there. Okay. So that angle is 54.5 degrees. Okay. This whole rest of that would have been 55 degrees. Okay, so that's how I knew it was a little bit above that. All right, so the bearing, here's my control tower. So the bearing from the control tower would be north, and it's not going to be all the way, it's not going to be all the way to 55. See how that, let me erase that part. Okay. So it's going to be the 35 together with the 54 because that's how much it's off from the horizontal. So that would be 89.5, north 89.5 degrees east. Okay. North 89.5 degrees east. All right, so that one, the only hard part on that one, what was hard for me to draw, is I didn't know when I put in the 5 and the 7, I didn't know whether the 7 would make it go to where it's below the horizontal or whether it's above the horizontal. And so it really turned out to be above the horizontal. And so it wasn't really this picture, okay? It actually, the 7 stopped higher up. So it was just above that line. So that's what was confusing. So this picture didn't really match it. It was this picture. All right. So you had your control tower. You went north 35 degrees. So that was only this little first bit just to here, east. So there's your plane going along. He goes 5 miles that way, turns 90 degrees. Okay, here we go. On a bearing from there, see the bearing from there would have been south. This would have been 55 degrees east, okay, and goes for 7 miles. And then you want to know the bearing from the control tower. And so we had to go and think about that. It was north, and then we veered a whole lot to get to there. And we found that this little angle right here was 54.5 degrees. And so that, together with the 35, gave us how far from that north-south line you were That's where the 89.5 degrees came from. Okay. All right. So that was 57. And then you can stop the video if you want and try the even ones, and then come back and I'll just write down what the answers are to the even ones so you can check them, and then let me know if you need me to go over any of those. Okay, so stop the video and work the even ones from there just to see if you've got this. Okay. And I'm just going to put the answers in right now. I'm not really going to work them out. All right, so south and east. Okay, I think these are right. South and 36 miles east. Okay, 54. Wanted just how far one ship was from the lighthouse. That turns out to be about 13.3 miles. Okay, on 56, it wanted a bearing that the ship should sail. It turned out to be north 56 degrees west. And then on 58, it wanted the bearing of the ship from the port, and that one would turn out to be north 82.5 degrees west. Okay. So if you want me to go over any of those, just let me know and I can do that. Just wanted you to have some exposure to those bearing problems. Okay, so I'm going to stop this and open up the homework on 5-8. I really want you to work on getting that done before we get back together next week. So don't stay stuck on that test 1 stuff. You should have already been prepared for that, ready to take the test today. They just closed campus, or we'd be doing that. So spend some time doing this 5-8 work, and then maybe look over the material for your test when, like on Wednesday, and be ready for it on the following day.